So thanks for coming to my talk today. I'm going to talk about red teaming in 2018. So if you're in my talk, you've probably already heard of the term red team, and you sort of understand what red teaming is. But over the years, I've always heard of people use the term red team, and there's many definitions for it. And when we go back to the roots of where red teaming originally came from, the concept, it stemmed from roots in the military, the US military, for example, to be specific. And there's a definition that I found on Wikipedia, not the most trustable source, but I think it sums it up pretty well. So a red team or the red team is an independent group that challenges an organization to improve its effectiveness by assuming an adversarial role or point of view. So the key points being that the red team should be an independent group, and it challenges the organization and it assumes an adversarial role. So let's keep that in mind throughout the talk. So over the past few years, I've spoken to a lot of cybersecurity people, even though the term red team doesn't necessarily only exist in cybersecurity. It can be used in the legal industry, for example. So let's say you're red teaming the legal papers for any loopholes, for example, or anything that you might have missed. In cybersecurity, these are the sort of terms that I've heard from cybersecurity professionals. So the first definition being open scope. This is mainly, this group of people, this definition mainly consists of penetration testers, people that have a lot of hands-on keyboard experience with hacking computers, hacking networks, etc. And the term, this usually, this open scope idea is that you can break into an organization in any way you want, including using techniques such as social engineering, phishing, or maybe even go to the physical offices and social engineer and walk your way into the offices to start looking for access to computers. The second definition that I hear a lot of now from more mature red teams out there, and people that have been working a lot with blue teams and security operations centers, is train the blue team. So essentially, we're here to help understand the detection and response capabilities of the blue team of a customer's organization, and assess the overall resiliency of that organization to a real cyber attack. The last definition that I hear the most is objectives. So from my understanding and the way I think of red teaming is that a cyber criminal comes and attacks an organization or performs a cyber attack. There's always a motivation backing that attack. So if I'm after financial data, I might attack a shop or something for a shop, for example, for credit card data and such. So there's always a motivation. If I'm looking to conduct espionage on a competitor, for example, I might attack that company and start looking for any R&D data or intellectual property that they might have developed. So that sort of thing. So there's always the motivation behind the attack. And when we start considering the motivations behind the attack, we start having goals that we want to achieve. Like I said, with getting credit card data, getting health data, personal data of the employees, transfer X amount of money out of the organization. With these goals in mind, we don't necessarily always have to go down a technical approach or a specific path to obtain these objectives. We might be able to come up with shorter paths, more effective paths, like a pen tester or someone that's used to confining themselves to a small scope might not necessarily think of until you start trying to think outside of the box. So red teaming isn't necessarily just a technical assessment. It's not necessarily just for the technical folk out there. So it can be used for strategic types of objectives as well. So if you're here to assess the overall resiliency of your organization, you might go and opt to go for a red team assessment. You're here to, if you're like the management, you want to know, can my organization be hacked? Can an attacker get access to this specification for this new products that I'm making, that sort of thing. And being able to understand that and see how it might be conducted, you can start adding new layers in between the attack chain and we call it like defense in depth, essentially. And even if you can't prevent the attack, if you can always detect the attacker, then you can start bringing in IR experts, threat hunting experts to begin pushing these attackers out of the organization. But if you can't even detect the attacker, then there's no way for you to begin doing that. But of course, there's always the tactical side of things. So if we're conducting an attack, there are vulnerabilities that we might exploit, there are controls that we might exploit, security controls. So from that, we can discover these gaps and we can plug those holes in from a tactical point of view. So as we can see, it's probably not about getting domain admin, it's not about pass the hash, SQL injection, or getting all of the data in their company. So from a threat actor's point of view, they're after a specific set of data or a specific type of data in that target organization. You know what you're after most likely before you enter that organization. At least the sort of generic idea of like the direction of the type of data that you're looking for. I've met many red teamers so there's teams that I've led and there's people that just break in, they've got an access, they're like, oh, we need to get domain admin so we control everything in the organization and we're going to get all of the data from every database. But no, sometimes when you've set in the goal and you know what you're after, you go for that one goal and you don't have to create unnecessary noise for the blue team to detect. So quick disclaimer, cybersecurity laws are changing in every country and I can't represent every single country. So if you're going to use any techniques I talk about in the talk, then check with your legal teams before you use any of the techniques. So who am I? I'm Vincent Yu. I run a firm called Science Security. We're based in Shenzhen, China. I've seen a lot of technical security firms out there, and I really wanted to bring more of an adversarial mindset type approach to security assessment to the Asia region. There are existing vendors out there that are pretty good, and yeah, I'm just trying to further encourage red teaming in this region. I have a blog, vincentu.co.uk. I'm quite well known for the red team tips that I post. I'm up to around 330 now. So it's team tips, but blue teamers will also benefit from this. You might get some idea of how a red teamer thinks, and then you can use that to start creating controls to detect an attacker. I'm also CREST certified. I have OSCP and OSCE as well. Spoken at a couple of conferences, JD.com's conference in Beijing last year, and Hack in the Box last year and a few other conferences. So for the agenda today, I'm going to talk a bit about domain enumeration, email enumeration, GitHub, mainly because I've had some real good quick wins this year because of GitHub. Going back over domain fronting basics for the people that have missed it over the past couple of years. And there's some pretty good updates this year, as there's a lot of news coming out around domain fronting. And understanding email security once and for all, because there's a lot of people out there, a lot of organizations, they think they've set email security correctly. People can't spoof their emails, etc. And I'm just here to clarify and give some more ideas around how we might be able to spoof emails or use a trusted entity to give a bit of add a bit more trust to your phishing campaigns, and a bit about Office 365 as well at the end, like my friend Jonathan Echevarria did, and some extra work that I've done on top of that as well. So I like to map my talks sort of roughly to the cyber kill chain by Lockheed Martin. So it covers reconnaissance, weaponization, and delivery today, but there are other areas. If you've been red teaming for a while, you'll know that although the cyber kill chain does model and map out the attacker lifecycle pretty well, there are gaps in between, and there are loops and iterations of reconnaissance that you might have to do. After you've breached the perimeter, you still have to do more internal recon, or as some people call it, adversary onboarding, after you've breached the perimeter and understanding the internal network. So it's not always, solid steps as to how an attack might be conducted. The actions on objectives here at the end is a lot broader than just one phase, I think, personally. And there is a lot to be done in that area. It's quite difficult to share in that area because of the sensitive nature of the work that every speaker does for the clients and NDAs, etc. So I'm going to go over the first three phases today. So in terms of reconnaissance, there's passive and active recon. Passive being like you don't actually touch the target infrastructure, you gather information indirectly. Active recon being you touch the target infrastructure, you might scan the infrastructure, or you might probe the infrastructure. So there is some small chance that there can be detections placed to detect active reconnaissance. So if there is a really good blue team out there, they might be looking for any active scan probes out there on the internet. Let's move on. The first tool I created around February this year was called DOMLink. So the reason why I created DOMLink was so that I could expand my attack surface. I had a few customers where they'd give me a domain name. So, well, they wouldn't give me the domain name. I'd know what company they are, and then I'd find the domain name, the first result on Google. And then they have acquired many companies over a long period of time, or they have many domains that belong to them. So I went ahead and created a tool called DOMLink, which allows me to expand that quite easily from just using the tool. This tool is also being adopted by many bug bounty hunters because it's pretty good for discovering obscure infrastructure that might have been set up by the organization but left behind. And those usually might be unpatched, etc. So bug bounty hunters have been using that as well. You get the tool at the bottom here, and I've got a blog post about how the tool works. Here's a demonstration of the tool. So I begin by running the tool on uber.com in this example. And it asks me, do I want to check Uber Technologies Inc.? So I say yes. And then domains at uber.com, and I say yes. So I basically say yes to anything that I am certain belongs to the organization. So like the 17.19895, I'm not 100% certain, so I'll say no to that. So after you fill out a bunch of these, you get a lot of domains come back that are potentially owned by the customer organization. So I wouldn't have known that Philly Airport Limousines, and well, I would have known Uber Eats belongs to Uber. But there's also other divisions like UberRobotics.com that also belongs to Uber. So this helps you expand that attack surface quite significantly. And then you can perform subdomain brute forcing and all of that, the traditional stuff that you did with vertical domain enumeration to this set of domains as well. So over the past couple of years, everyone has started to become aware of social engineering attacks and spear phishing, for example. So when we're trying to do spear phishing and sending emails, we need to have access to email addresses. And to get email addresses, traditionally we've used tools such as the Harvester, Google Dorking, looking on the website, contact pages, and then there was social media. So people started using LinkedIn to find employees that belong to different organizations. And I recently looked at another social media network called MyMy. When you can get these employee first names and last names, or even the middle names sometimes, you can potentially predict what their employee email address might be. So last year we released LinkedIn at Hack in the Box as well. It scrapes LinkedIn, but it was limited to around 1,000 results for that organization. You can get it at the link here. And MyInt is a new tool that I've written. So last year I spoke at JD's conference in Beijing, and some of the delegates came up and told me about a social media network that was more used in China called MyMy. So I went and took the MyMy mobile application. I intercepted some of the comms, extracted the API that they were using to communicate in the backend to grab the information. I've got a pretty good blog post here at the bottom on my blog, which goes through the steps necessary to do this sort of API extraction from a mobile application, if you want to learn more about it. So there's no limit on the number of results that you can fetch back at once from the MyMy application. And it's mainly used in China. So you might be thinking, this tool might not be useful for me because I'm not in China and I'm not targeting Chinese employees. But the thing is, if your customer has some presence in China, then there's ought to be Chinese employees, right? If there's Chinese employees, then you can potentially get more emails that you can also phish, even though the target is in China. And sometimes if you can land a shell on an employee that's in China, you can always put over to the other areas of the company, from my experience. So here's a demonstration of the MyInt tool. I begin by inserting the target name in Chinese. So I'm using Weipinhui. They're a e-commerce company in China, VIP shop. The domain is vipshop.com. They're quite well known in China, but not so much outside of China. I put auto here to basically automatically enumerate the prefix for their email addresses. Here I've found 980 records immediately. I've had times when I could fetch up to 20, 30,000 employees all at once, and I can dump it all in one go. So this is a CSV output from the tool where you can have loads of email addresses for the different employees of that organization. This is the job title here in the third column, so you can read through that as well. Google Translate works pretty well if you can't read Chinese. And then I've got a HTML report as well, which has their image. So the image might help you understand what gender they might be, their sort of age range, the sort of activities they might be into. So this definitely helps you contextualize your spearfish if you're doing it in a one-to-one or one-to-two basis. So what next? After you've got this large list of emails, you might be tasked to, all right, I'm going to send out a small batch of emails to 20, 30 people. But then what happens? You expect that an email will go through, like so, but it doesn't really all go through. You get a bounce from that email. Because all of these emails were actually predicted, they're not validated, they're not 100% correct, you might get some incorrect emails. And when you get incorrect emails and you start getting bounced by the email server, it starts damaging the reputation of the email server that you're sending from. And when the reputation is damaged, all of the emails start going into the spam box, or it starts alerting the blue team. So this makes it even more important that you should validate your emails before you go off and pick your targets and send emails. The three most popular sort of techniques I use for email verification is I go for bounce checking. I'll go over that in the next slide. Exchange timing attacks. I'm not going to go over that now because it's quite well known already. So for on-premise exchange, Daft Hack. So Bu Bullock wrote a tool that allows you to do username enumeration using the timing between login attempts. So when you log in with a valid user ID on a Windows machine, it takes a little bit longer for it to respond because it has to go and to check the password to see whether it's correct. But if the username is incorrect, it'll just respond immediately and say like the account login is incorrect. And then there's also Office 365 username enumeration. A lot of people are using Office 365 now, and it's even better than the exchange timing attack because that was based off the timing and the responses. The Office 365 username enumeration was it's an error-based username enumeration. So when you log in, you get a different response if the password's incorrect, but the username is still valid. A person called Grim Hacker wrote a tool to already do this. So always do this behind a VPN as well or through a proxy, because I've seen many times where even my old colleagues, they would perform this sort of attack to be able to get a valid list of emails, but they accidentally leak their IP address. And do it in a virtual machine as well if you're using like PowerShell, for example, in Mail Sniper, because you start leaking your host name. And when you leak your host name, it doesn't look good if the blue team detects that and asks your point of contact, is this you? So just a bit more OPSEC to make things realistic when you're performing these sort of engagements. So back to the bounce checking. This is something that I quite enjoyed this year that's come out by SDWolf32. He's written a project called TrueMail. So if you're not aware, quite a lot of the bounce checking services previously for checking whether emails are valid cost quite a bit of money. And when you're buying like 10,000, 30,000 credits for that service, it all adds up quite fast. But SDWolf32 basically dropped the source code for his tool. So you can set up your own dedicated server by simply installing Docker and then grabbing the repo from his repo, and then you can run the tool. After you've run it, you can specify your email address at the end. So I can see that vincentu.scienceandcuriosity.com is deliverable, and it's true. But always make sure that you also check for invalid emails. Because if you put an invalid email here, you'll see deliverable is false. If it says true as well, there's potentially like a catch-all email, and then the bounce checking won't work. So just to keep in mind before you think every single email that you checked was correct. So now on to a bit about GitHub. Oh, so GitHub's the root of quite a few massive fails that I've found this year for even Fortune 100 companies that I've tested against. And I found a lot of usernames and passwords leaked onto GitHub. And even in some cases, stuff that could potentially influence like governments, like for countries, etc. So I'll go into that in a second. So in terms of GitHub, we all know you can get credentials, secrets, access keys, and I found that you could actually get some pretty good sysadmin notes sometimes for systems. So I've seen some of the sysadmins post entire debugs that they've done for internal systems, like system logs, etc. So all of that is really useful in contextualizing what sort of databases I might be using, what sort of technologies. So GitHub is a treasure trove of information. In terms of operation tips, when you're doing this sort of enumeration, I prefer to do it all manually, because when you're doing it manually, you can dig through each of the repositories. Sometimes it's not named password as a variable. You have to read through the source code to understand how it all works, to be able to then identify like there's a password leak right there, or there's a access key. I don't use tools like Trufflehog or Git extraction tools. I used to, because I thought it was a good way to just quickly check through GitHub, but it actually only checks for the organization that you're specifying. When you're searching through GitHub, you want to use GitHub's search engine to let's index the entirety of GitHub to find these sort of flaws and leaks. A quick shout out to Xiaomi Security Labs. They created a tool called X-Patrol. It's in Chinese currently, but you can Google Translate it to English. It'll help translate the tool to English. It runs as a service on the server. And basically every day it will go to Google, and no, it won't go to Google. It'll go to GitHub, and it'll search for your company name and look for any sensitive records that might have been leaked. And it does this every day, and it starts putting these as issues into the system, the web application. Then you can log in. So you can have your blue team can have individual accounts, and they'll be assigned these issues to manually review and audit on a daily basis, maybe. And it can potentially send emails as well to you when a new thing's been posted by someone in your organization, or maybe even outside the organization. So definitely worth checking out if you're on the blue team. So what did I mean by using GitHub search feature? So at the top of github.com, you can even do it on your phone right now if you put your organization's name here, and then I like to use words like SMTP, FTP, and password, because I've seen loads of people write Python scripts to quickly send emails using their company's SMTP server, and it leaks their password then. If you know the company's internal NetBIOS domain name, you can use, like, for example, dom.eu1.corp. That better identifies and gets better information usually, so there's less noise. You find sensitive information that's related to the internal FQD. So examples of some of the quick fails, I haven't censored some of them out. It's too small for you to see anyway, so it should be all right. Usually it's config files and there's passwords here and there. I've done a few bug bounties where passwords were still there, even though they had people checking GitHub every day. So you can go back maybe as far as 10 years and sometimes find stuff that's not been changed. Here are some, these you can't see too clearly. They're switch configs for a telecom in China. And that was quite well widespread. I cracked the hashes, and yeah, the passwords look pretty legitimate. I reported that to the Chinese CERT, and they said it was test data, so yeah, we'll see. And when I'm moving on to weaponization now, I'm going to focus on command and control, because weaponization can go into payload types, exploit 0 days, all of that sort of thing. But command and control is the main area that I've been working on in terms of bypassing and establishing a secure channel just into the target organization so that I can control things remotely. When I'm talking about command and control, we can't not talk about domain fronting. It's a technique that's been used for quite a long time now, mainly by services such as Tor and Signal for bypassing censorship issues in certain countries. But before we go into the main bits, I have to explain a little bit about domain fronting so everyone understands. So at the top here, when you're connecting to a website, you usually connect directly to the server and then issue it a HTTP request to grab the web page that you want. When you're using a CDN, you're basically setting your domain name to point to a CDN. And when you point it to a CDN, when your machine starts resolving like DNS query, it'll point to a CDN edge node, as we can see it. So when your machine wants that website, it establishes a TLS channel to that CDN node, edge node that has your private key, and that's a secured channel then, and it's not supposed to be intercepted. Okay, and during that, after the TLS has been established, you actually send a HTTP request across it with a host header of, let's say I'm looking for gotomeeting.com, then it will grab gotomeeting.com's origin and grab the content, send it back, and send it back to your machine. In terms of domain fronting, what's changed is, say that was gotomeeting.com after it's established the TLS channel, you're establishing the TLS channel and then changing the host header so that when you send that HTTP request down that channel, you're saying, actually, I want to grab data from my origin, so my malicious instance. Here I'm using nice.try, but no. So on Amazon, you can actually have arbitrary CNAMEs, so you can put any host you want. It doesn't have to exist, and it doesn't have to be a legitimate domain name. So that's sort of changed in Amazon. I'll go over that in a second. So people have said this is dead now. Is it dying? I've had a lot of people ask me on Slack channels, on Twitter, etc., whether domain fronting's dead, whether we can still use this technique. So Google says they've disabled domain fronting now. Amazon says they're threatening to shut down Signal's account, and it's against terms of service. As we can see here, we're happy for you to use AWS services, but you must comply with our service terms. We'll suspend your account, your use of CloudFront if you use third-party domains without the permission to masquerade as a third party. So just make sure your company's comfortable with you using domain fronting in case you get them suspended for whatever reason. So people have looked at Amazon CloudFront for domain fronting, Google Compute Engine, and Azure. Not so much in Alibaba Cloud and more Azure clouds, as we can see down here. I've done quite a bit of research into that. So sometimes maybe you want to simulate an APT or a Chinese website, then you can use Alibaba Cloud, Baidu Cloud, Oppo as well. So more options there. Okay, so in terms of Google's domain fronting, we used to be able to domain front through www.google.com, mail.google.com. And basically, it would look like your traffic was going to google.com, but instead it's actually a command and control channel to your website, your command and control server. So the old way was to specify a host header to your AppSpot engines, your AppSpot domain. So on Google App Engine, there was a way for you to spin up your own app and redirect traffic to your team server. But now, when you do this, you get this new error message by Google, a 502 saying bad gateway, basically, due to an infrastructure change. That was their way of stopping it. But instead, actually, Google doesn't just use App Engine. There's other services out there, such as Less Storage. So Less Storage being an equivalent of, say, S3 buckets on Amazon. If you connect to a storage instance through google.com or mail.google.com, you can actually still grab content from your own storage. So you can use this to send malware through www.google.com or mail.google.com. So just a quick change that you can even create your own C2 channel using storage if you wanted to. So the majority of people that I know have been using google.com, etc. for domain fronting, but they haven't necessarily thought about using Google's customers' domains for domain fronting. So there are actually, believe it or not, a lot of health domains on like use Google App Engine, and there are a lot of government domains that also use Google App Engine. So you could masquerade as these websites to establish that command and control. Unfortunately, it doesn't work anymore. If you set a host header as .appspot, you'll get a similar sort of error message and bad stuff there. But what works is if you set a CNAME, custom domain on that App Engine instance, then this will work. You can establish that command and control channel through the customer domains. In terms of Amazon, it's use at your own risk because it's against the service terms. So they might switch off your Amazon AWS account if they detect you using it. I've not had any issues. I'm still using it. It works fine. Yeah. So it's also the largest selection of domains for fronting to date because I've made a massive list public and people can find whatever domains they want to use. I've got a list down here. It's really big. You can find a lot of reputable domains in there, and I'll go into that in a second. So yeah, and you can also have the arbitrary host header of your choice. I've got blog posts on my blog once again about this if you want to look into it in more detail. Azure has been growing in popularity, and it's started to overtake, say, Amazon in adoption. And a lot of customers are beginning to use Azure. And that means that being able to domain front through Azure means that we can blend in a lot easier with their normal traffic. And a lot of people might not be aware, but it was way over a year ago since the Obsidian Tower actually wrote a really detailed blog post on how to set up domain fronting on Azure. So just keep in mind that you can also use Azure for domain fronting. You can use domains such as csrl.microsoft.com or Skype. And there are actually also customer domains that use Azure, like I said. So there are government domains there as well. I've got a list here down on my GitHub as well. And there are the other vendors. I haven't gone into it in the presentation, but there are YouTube videos on my channel that you can also watch, and I go through the demonstration of setting it up and getting it working. All right, so I've spoke all about domain fronting now, and so why domain front? So there is TLS inspection in a lot of companies now because there are web proxies, and it allows the blue team to start analyzing the traffic and see what's coming in and out of the organization. You can block malware. You can start detecting whether there's any known command and control sort of indicators in the traffic as well. But in a lot of countries and companies even, they have to abide by, say, regulations like HIPAA, so that health category can't be inspected, or there's an implicit trust in health, government, and financial websites. And this makes it so that if you can domain front through any of these category websites, then it's not intercepted. So all they're seeing is a TLS channel that's been established to that target domain. And they won't be able to see, they can see the traffic volume, but they can't necessarily see what's being transmitted over the channel. And in terms of performance issues, more regularly accessed websites like Google or Mozilla, etc., might not be intercepted or logged on the scene due to it's going to use a lot of space, basically. And at NewP1 published quite recently on Twitter a default exemptions list for Palo Alto. And we'll see how this is useful in the next slide. So here on the left here is a list that he's published on Pastebin. It's the default exemptions list that comes with a Palo Alto a gateway, a web gateway sort of thing. And on the right here is a list that I've cross-referenced to the domain front list for CloudFront that I originally created. We can see that there's Mozilla, Citrix, GoToMeeting, Periscope Online domains in here. There's logmein.com as well. So if you connect to use any of these as your domain front, it won't actually be intercepted by a Palo Alto firewall. You can get that list down here. So I've spoken about getting emails and setting up the command and control and getting your payloads working with a pretty good way to set up the command and control and getting it past these filters. But then sending emails it's pretty easy right now because email security is hard. A lot of organizations struggle with it. Not all firms will always point out there's an issue with email security because there's different ways of sending phishing emails. There's different emails you might want to spoof, so that sort of thing, and it doesn't always get picked up. But when we're talking about email security, we need to definitely mention the Sender Policy Framework, SPF, and the Domain Message Authentication Reporting and Conformance, so DMARC. DKIM, I'll forget that for now because a lot of people can't even get the basics right. You have to get the basics right before you can start thinking about DKIM. I can't stress this enough, but SPF is useless without DMARC. So if you don't even set up DMARC, there's no use in setting up SPF. You can, we'll see why in the next slide. So always make sure that DMARC is configured well and SPF is configured well at the same time. It always turns out the same. I've had security companies tell me that, oh, you can't spoof our emails. But next thing I do is I show him that, I can send an email into your organization as your boss to you, and yeah, it goes in fine. There's even times where we'll go into it a bit later on as well. I'll show you guys with some Proofpoint and Mimecast examples. But in terms of SPF, the idea is to specify a list of IPs and domains that are allowed to send on behalf of your trusted domain. So let's say I'm bankofabc.com, then I only want this IP and this IP to be able to send emails as my bankofabc.com. Okay? But one thing I'd like to highlight here is that a lot of marketing departments and HR, well, not HR, PR people are wanting to use all of these services that do all of the branding and marketing for you. And there's all these shared SMTP servers on the cloud now. So just keep in mind that if that vendor, that third party is giving you, letting you use their SMTP server, there are other customers that can also use that SMTP server. If it's not configured right, someone can just be a customer as well of that SMTP server and then send emails on your behalf. So just keep that in mind as well. So when getting an SPF record, you do a DNS text lookup for the domain and you get this blob, this SPF record. This is a pretty well configured one by Microsoft, which specifies what domains are allowed to send on their behalf. In terms of DMARC, this controls what happens when SPF fails for an email. So if there's no DMARC record whatsoever configured and it fails the SPF, so if I'm sending an email from my IP, but it's actually not in your allowed list, it will still let it through. It will make it into your inbox because it fills open and allows the email. And also in some bagged configurations, you can also spoof the email. To get the DMARC record, you do a text record lookup once again for _dmarc.domain.com, so yourcompanydomain.com. And here's a pretty good example from Microsoft where the policies reject. So in terms of the policies that you can have, there's a P for the policy flag and SP for the subdomain policy flag. When you're looking at the DMARC policy for the target organization, from an attacker's perspective, it's good when it's set to none, because that just means it makes it straight into the inbox as well. It's not saying that you don't have a DMARC record here, you do, but it's set to none, so it's bad. A lot of organizations set it to quarantine because there might be compatibility issues, or you might be worried that you might lose some emails that you're trying to spoof to yourself for some reason. And the best configuration is to just have it on rejects if possible, but that's difficult to achieve if you don't want to lose emails. So this is the sort of recommendation I give when setting a DMARC record. Oh yeah, so when you set quarantine to the spam box. Next slide. Yeah. Okay, so even if you set a good DMARC record for just the root domain, what about the subdomains? So here's a quick example that I found that had a bad subdomain record policy, so the SP8 record. We can see here that they've set up good SPF, really good SPF, it works. And then there's a bad subdomain DMARC record. So there's a SP equals none here, if you can see, but the P is reject. So if I spoof on behalf of the root domain, then it won't make it into the inbox whatsoever. If I set it to none, if it's set to none, then I can spoof a subdomain. So I can use something like secure or securemail.companydomain.com, and that still looks pretty legitimate in most cases. Here's just an example that I did. Sent it from this output.bank.com email, and it makes it through because of this misconfiguration. Thank you. Okay, so what happens if you can't spoof Microsoft.com, but you still want to pretend to be Microsoft? You can try and spoof the TLD. Yeah, believe it or not, you can actually send emails from no reply at Microsoft and it'll make it through. Because you can't set an SPF record for a domain that you don't own. You can't set a DMAC record for a domain that you don't own. So here I've sent rainbow at Microsoft. To some employees, that looks legitimate enough. It looks a little bit weird. Where's the .com gone? But it works. So yeah, you can't set an SPF and DMAC record or email security for a domain that you can't own. It's good enough in most cases, but yeah, it's all about the branding and what you're trying to make the email look like. So it all helps. And we can't finish talking about Office email security without talking about Office 365, because now it's pretty popular and a lot of organizations are using it. I did publish a list of tenants for Office 365. So there are a lot of tenants. There's a link in later slides. So there are email spoofing issues in Office 365 uncovered by Jonathan Echevarria at Underflow. He discusses mainly bypassing Proofpoint if you're using Proofpoint, but accessing 365 directly. He's got a really good blog post that he published. He's not that well known, but it helps to check out his blog post as well. He's got a lot of interesting content. So what happens when you usually try and send an email is you do an MX lookup for the domain that you want to send to, and then you get an IP for the mail server. So the secure mail server, if you're using Proofpoint or Mimecast, for example. And then you send that email to the secure mail server. It'll go through its whole filtering process and cleansing process to make sure there's no bad stuff in the email. And then it'll forward it to the final destination on Office 365 if it's all good. What Underflow found was that if you connect directly to the Office 365 server, you can just send the email to Office 365 and bypass that fancy box altogether that you're paying money for. And then all you're left with is Office 365 decent filtering, I suppose. And this does involve solutions such as Proofpoint and Mimecast. I tried to give some examples, but these were the two that I most commonly see. So that just says bye-bye to your security investment that you tried to add an extra layer for. So how do we exploit this sort of thing? And how do we know where we can use this attack? So we know whether a target uses Office 365 blindly by doing a DNS request. So what you can do is if your my company domain is your .com is your website, then you can replace the dot with a dash. So like I've done here, you get my company domain-com. And append mail.protection.outlook.com. If you do a DNS request, if it comes back with anything, then you get an IP address. If you get an IP address, it means that they're an Office 365 tenant. If you don't get anything, then it just means that you got to use a different spoofing method or attack. So in China, they tried to segregate things in partners and all of that good stuff. China has their own domain here at the end. So for China and Germany, it's sort of different. I've created a tool called Checkhole365, which basically just does a bunch of DNS requests to check whether they're a tenant. Because I made this tool because I was checking through billions of domains, so I wanted to script it up. So how does it work? Office 365, you can connect directly to it and send emails because it doesn't use authentication. There is a caveat. You can only relay emails from Office 365 tenants to other Office 365 tenants unauthenticated. So in terms of an example exploit you could potentially use to send an email from Microsoft.com is send an email from rainbow at Microsoft.com, my example, to user@tenant.com. So that could be any Office 365 tenant. And send the test email using your tenant's mail server, essentially. And it will go through. I've tested this. I've tested it quite recently as well, just once again. There is so I've sent the email into an Office 365 tenant, rainbow at Microsoft.com, and I've attached a macro Word document, and it's bypassed the Proofpoint and Mimecast filters. So it's made it right through. And in terms of the web, if you're accessing the email on a web application portal, you even get this nice Microsoft logo here, just to add a bit more branding and trust in the email. I've mentioned China and Germany having other regional Office 365 servers, etc. And I just wanted to make sure that I could relay between the regional tenants as well. And yeah, that is indeed possible, just to make it a bit more complete. So I was spoofing emails, and I was sending my friends and customers lovely emails from Microsoft.com just to test their Office 365 and show that it works. And then eventually I hit this error, a tenant inbound attribution error coming from the SMTP server. And it basically says it's something about restricting domains to an IP address or a certificate. And what popped up in my mind was, if I wanted to stop this attack, what would I do? I'd make it so that the Office 365 server only receives emails from my Proofpoint server or my Mimecast server, right? And that might have been the sort of configuration that a certain tenant or client I was testing with tried to put up in their configuration. But I found a way to bypass this. So it's quite trivial, but I found that if you just use a less secure Office 365 tenant, you can relay it through their server to the target server. So I'll show you what I mean. So when sending the email, if you send it from rainbow@microsoft.com and you send it to user@tenant.com, so the target, but instead of using the tenant's mail server, use another tenant server that is less secure or not configured well, and then it will still relay an email to the target. So there are some issues with this. Office 365 has a spam filter. Sometimes it does block emails, sometimes it doesn't. Depends how suspicious your email looks, I suppose. I recently started having issues spoofing Microsoft.com. Yeah, with a customer, I tried to send some emails, and then yeah, no one was clicking. I was wondering why, and I realized that when I was spoofing Microsoft.com with certain TLDs in the URL, such as .host space, they're flagged as spam, maybe because they're more used by malicious threats and like spear phishing emails and spam emails. So yeah, I figured that if you just use .com, it works fine. So don't use the dodgy looking domains, even if you're trying to pretend to be like client and or like customer and register a domain that looks similar to theirs. So always test the spoofing, and Microsoft's making some really quick changes to their environment, I think. It might be that, or their natural language processing on the emails that I've heard about. There's a bit around that as well, just make sure your emails work before you send it in large quantities to the target. So any questions? I'm vincentu.co.uk, and you can check out my blog there, some posts. And I'm VY Security on Twitter, and I've got a WeChat if you want to add me. You can get a business card off me and add me on Signal if you want to chat about Windows Privask or any other cool stuff. I've also got another demo here, actually. So I've been working on a thing called the USB Ninja that I thought I'd show you guys if you haven't seen me at my booth. I'll show you what it is. So I've got around 10 minutes left. I'll quickly show you guys. So this is it looks to be like an Apple Thunderbolt, what is it? Yeah, Thunderbolt cable or whatever you call it. But anyways, it's an Apple cable and it can charge my phone. So can I just get a volunteer? You got an iPhone? Yeah? Yeah. So.
Last you'll see of it.
Let's see. You might not be able to see at the back, but just take my word for it for now. I'll give you a personal one-on-one demo if you want one. So I plug in this USB, right? It's not doing anything really. It's just I'm just going to show you that it's going to charge and you can transmit data over the cable.
I'm not going to regret this, right?
No, okay. Hope not. Right, so I plug it in, right, and it's charging, okay? So you you won't be able to see, but this gentleman will tell me like it actually works. It's charging his cable. I don't think you can show them, so because you don't have a camera. No, it's okay. So yeah, so it's charging his phone, and can we just show them that the data transfer works as well? If what's this? Oh, okay, USBninja.com. if I go to Apple iPhone under my computer and internal storage, DCIM, I can actually see his photos. So the data transfer works two ways. You can actually you can use it as a normal Apple cable as well, to do the data transfer. You can also develop iOS applications on it. We've got a micro USB version. We've got a USB Type-C version of this cable as well. So yeah, you like to use the cable, right? So I've got a Bluetooth remote here with two buttons. Let me just close it and repair it. Okay. So there's two buttons, an A and a B. I'm going to trigger a bit payload. So without triggering this, you can use this cable on a day-to-day basis to basically, say if I'm traveling, but I don't want to pop myself every time I want to charge my phone, for example, right? So I don't want to have to shut down all my shells. So if I press A now, I can make it attack on demand. Oh, interference. No, it's attacking. So it's just popped up a shell quite quickly. Took around 4 seconds. Then actually, let me see if I can show you here. On this here, you can actually see that. Oh, yeah, right, whatever. I've got too many shells now because everyone's been. Okay, so if I do a PS, beacons every 5 seconds. This machine is now actually connecting out to CloudFront and connecting to a server in Tokyo. And this machine can be anywhere in the world, and it's connecting to that same command and control server, and I can control that machine remotely. You can also screenshot, and you can control the machine however you want. Oh, I've got so many screenshots. But here's some examples of just screenshotting the website. Does it return? Takes a little bit of time. Yep, screenshot received. So here's a screenshot of the desktop that's shown right here. And then there's a secondary payload. So if I type B, it's just going to do a bit of a Rickroll type disruptive payload. Okay, it's triggered. So the sound's off, so there's not going to be a Rickroll, but yeah, it makes it look like a fake Windows update. So the idea is you can actually program multiple payloads into this and use it whenever you want. You could potentially have a OS X payload in the second one and a Windows payload in the top one, and then whoever's machine you plug it into, you can trigger a payload at will. So that's part of the tools that I've been working on since I went to Shenzhen. I've also got a magnet here. So let's see. Can I just duplicate I'll just duplicate to make it easy. Okay. So I've got a magnet here. All right, I've got Arduino here. So if you're familiar with the DigiSpark, for example, it uses the same chip as the DigiSpark. We've got a payload A here and a payload B. So let's say I wanted to program this, right? I can compile the scripts that I've changed, and it will basically here then say upload the payload sort of thing. So I'll plug it in, and we'll see that nothing happens. Where's my? Oh, can I borrow your phone again? Well, it's not uploading anyways, and even if I plug in this phone, it's not going to do anything. Just to make sure everyone's on the same page, right? So nothing happened.
Famous last words.
But instead, I've got this a magnet here. So there's actually a hidden mechanism inside the USB. So when I plug in the USB, I can put the magnet underneath the cable. Oh shit! Wait, that's the wrong one. Let's do it here. Okay, I'm going to program it here. Okay, right. It still doesn't program, yeah? Okay, good. I'm going to plug it out again, and I'm going to use the magnet. I'll put the magnet underneath the USB cable. And it's uploaded the code onto the cable. So unless you knew the mechanism to upload code behind this, even if you got this cable, you wouldn't know how to upload code and modify the payloads on the cable. So this is useful for situations where someone might want to steal your cable, for example, or etc. So that's one of the neat tricks that Olaf Tam, the hardware engineer, came up with. So that's that. If anyone's got any questions about anything I do, let me know. Thanks for having me here.
Thank you, Vincent. A very interesting presentation. And before we wrap up for this talk, any questions from the floor? Or as always, we'll do questions off stage. He'll be around also for the post-conference party. Be sure to join us there as well for rounds of drinks with him. Thank you.
Thank you
very much, Vincent.